Hello class, we're going to be looking at Unit 3. Unit 3 is talking about how to write your program. And I know we haven't done a lot of Python learning yet, but we're going to start off by just giving a big overview on just in general how to write programs. And I'm going to break it up into 3 stages. The first stage I will call the development stage. In the next stage, I'm going to call that the debugging stage. And then in the next stage, I'll call that the testing phase. Okay, so let's talk about each of these phases one by one. In the development stage, before you start doing any programming at all, before you start writing any Python code, get out a piece of paper. Work out the problem on a piece of paper first. Solve it as if your own brain were doing it, and think in English. You know, how did I do it? What were the steps? Analyze it carefully in terms of what were the steps that you did. You know, write out those steps in English. Do not start writing it in Python. This is my analogy. Say you speak English and you're taking a Spanish class and you're just learning how to write in Spanish. You don't just jump to writing a whole story in Spanish. Probably what you do is you start off by thinking about your thoughts in English, writing out your paragraph in English, and then you translate that to Spanish. You're not good enough at Spanish to just immediately write out a story in Spanish. Same way with Python. It's a language. And so don't think that just because you know a little bit of the syntax of Python that you're going to be able to immediately write your program in that language. Start with the English language. Think about how you would solve it, not even worrying about at all yet how to make it in Python. Then once you have your English solution, then think about how to convert that into the program, into the Python language. In fact, what I like to do is I like to use my English steps as my outline in my program, and I will, even comment. So I will use Python comments like pound step 1, pound step 2, pound step 3. I will use Python English comments as a way of organizing the code that I'm going to write. And I'll start just by writing step 1. Then I'll write step 2. Then I'll translate that step 3 into Python. Now, as you do debugging, that's the next phase. Actually, the big tip to minimizing the amount of bugs in your code is actually to start in very small chunks. Always develop little pieces of code. Going back to this example over here, I would code up step 1. I would debug step 1, make sure step 1 is working. Then I go to step 2, debug step 2. Then I go to step 3. I don't try to translate the entire thing all into Python, run step 1, step 2, and step 3 all at the same time. So start small. Take it, kind of step by step. Maybe at the stage you're at, 2 to 5 lines, right? Just a handful of lines of code. Run it. See if it works. Do those 5 lines run the way you expected it to run? If so, then add a few more lines and keep on iterating and adding small things at a time. That's the best way of debugging, because in that way you don't have as, it's like finding a needle in a big haystack. If your haystack is really big, you're going to have a hard time finding that needle. If you have a little tiny pile of hay and your needle is somewhere in there, you're going to be able to find the needle a lot easier. So if you have a little small piece of code that you're running, then it's not going to be as hard to find where the bug is. If you have this humongous 10,000 lines of code and you just run it for the first time, it's going to be very difficult to find your bugs. So my tip is to incrementally develop your code, debug it in small pieces. Now, once you've done debugging that, then The last phase is testing. Now, testing is making sure that the code you wrote is good. Now, in Runestone, in this class, you're going to have a lot of these little snippets of code that I'm going to give you as problems to write, and you're going to see all the little green that's saying it's good, or all these little red that's saying it's bad. It's because I have, given you kind of some test programs that will test it for you. But really, that's not the real way of testing your code, by using my code to test your code. What you really want to do is test it out yourself. Put into your program some situations to try out the things that you are trying to do. So like if you're trying to figure out, one of the problems I've given you is how many quarters, how many dimes, how many nickels, how many pennies do you give back if you're, if you need to give 79 cents back. That's an example. So try it with other amounts, and not just 79. Maybe 26 cents, maybe 25 cents, maybe 10 cents, maybe 5 cents, maybe 0 cents. You have to dream up. You start with some basic test cases, and then you try to think of some boundary cases. And so, really big numbers sometimes, really hard things, or maybe even some very simple things. Maybe some border cases like 0 or 1. Sometimes those are things that might break your code. So you really have to be, this is actually a big part of developing your code, of programming up your code, making sure that your program is working properly. Okay, so I know that, in the beginning, a lot of your testing will be, you'll be depending on my test code to test your code, but I'm going to try to teach you how to write your own test code, not relying on mine. And in fact, when it comes to tests that you have, I'm going to give you programming tests. And for those programming tests, there's not going to be this magical, green or red result that you're going to be able to see. You're going to have to know, you're going to have to test your own code to see that it actually does function the way that I'm asking it to be. So you're going to have to learn how to write your own test code. Now, when you do get an error, when Python gives you some sort of error messages, there are 4 different types that make up 90% of the Python errors. There's what's called a parsing error, a type error, a name error, and a value error. And I'll go through what each one of these means so that when you hit it, it'll help you understand it and find where the problem is. A parse error. A parse error is a grammatical error in your code. You got this, what's called the syntax wrong. And so a lot of times I'll just use this word. This is the fancy word we always use in computer science, but it's basically you have a grammatical error. You violated the rules of the language. Examples, you might be missing a parentheses. You have print, and you have a beginning parentheses, but you forgot the ending parentheses. It's missing. Same with quotation marks. You start with the quotation mark, and then you forget the quotation mark at the end. Maybe you just put the parentheses. It's actually easier to forget these things. It might sound like so simple to remember, but this will be a very, very common issue of forgetting, a parentheses or a quotation mark. Now, when you get an error, Python will try to tell you the line number on which the grammatical error is found, the syntax error is found. It is not always perfect. It might tell you a line which you look at it and there's nothing wrong with it, and you need to look maybe before it to find the actual problem. So don't always believe 100%, the message of, oh, it found a error on line 5 and I don't see the error on line 5. Well, it could be because it's on line 4 or line 3. So just know that it's a suggestion of where it thinks the problem is. Okay, next kind of error is a type error. And, as the name suggests, it's an error where your data types are incompatible. Here are some examples. This plus operator in Python, we cannot mix the data type of a string with the data type of an integer. This is illegal. This will give us what's called a type error, i.e. a data type error. Mismatching data types. Same thing, this is the obvious case, and this is not typically where you will have problems because, it's obvious here I'm adding a string to an integer. But sometimes your error will be you have a variable and you forgot what that data type was. And so you do a string variable, say, divided by this integer 24. And in this case, you get a data type error as well because this variable here is actually a string, not some number. So it's more these kind of cases where you're going to have an issue where you're using variables and you forgot the data type that it was. Or maybe it changed into a string when you forgot it was a string or something, or thought it was an integer and you assigned it to a string accidentally. Okay? Typically, these are very accurately mentioned in the line error is typically pretty accurate in terms of where the error is. Okay, so what's the next kind of error? Next kind of error is what's called the name error. And this is when a variable is being used before it has been assigned. And here's an example. So A is equal to 5, B is equal to 10, and C is equal to D plus A. Now Python hits this line and says, what is D? I don't know what D is. It's unknown to me. I have no idea what the value of D is. I know what the value of A is. A is 5. But I don't know what D is, so I can't do this. I cannot assign C a value of D plus A because I don't know what D is. That is what's called a name error. A lot of times it's caused by spelling mistakes. So you notice right here, actually I highlighted the wrong thing here. You notice here, the variable is our without an S, but over here we're expecting ours with an S. And so little simple spelling mistakes oftentimes cause what these name errors. The last kind of error is what's called a value error. And it's not a data type error. It's very easy to mix this up with the data type error. But what it's saying is that the data type was correct, but the value of the data type doesn't work for this particular function. This is what I mean. Okay, so this integer function, it's okay to give it a string. Strings are okay. And so in this case, this variable here, number, is a string. So it's not an illegal data type. But the value of the string is no good. It's expecting a string that has a value of, 5 or negative 16 or something like that. It can deal with those values, but it cannot deal with the word 5. It cannot actually even deal with this value 3 period 1, 4. It's not smart enough. This function is not designed to work with this. And so it will give you what's called a value error in either of these cases. Okay, so really make sure you get the distinction between data type error and a value error. Okay, final tips on debugging. Big one. Use a print statement to debug. This is a very extremely useful way of understanding what your code is doing. You might have, many lines of code, and you don't know where the problem is, I would stick in a print statement somewhere in here to print out some variable value that's being used. Maybe x is equal to something here, and maybe down here y is equal to something, and so down below I might print out the value of y. And so this way I could find out what is, by adding print statements, I get a visibility into what the program is doing. Because print statements, not all programs have print statements. And it just has a lot of calculations of variables. And so you don't know what's going on when it's doing all those calculations. And so what you need to do sometimes is print out the value of these different variables. And you say, well, is it what I expected it to be? I expected this x to have a value of 5 according to what I believe, but it's not. Or is it? And if it's not giving you the right value, then you know, okay, I need to search around here. If the value of x is correct and it prints out, the correct value of, say, 5, then you go, okay, well, how about this variable down here? Is this printing out the correct value or not? And if it's not, then you know, okay, I need to kind of search around here where y is being assigned a value. Okay, so the print statement is a very simple yet powerful way of debugging. And at this beginning stage, I really kind of want to emphasize the use of this over other methods. Now, there is another way we could debug. It's with using this thing in Runestone that's called Code Lens. And I will be showing you this. It's a way of stepping through your program line by line. Line 1 executes. You get to see what happens in Code Lens. Line 2 executes. You get to see what happens in Code Lens. Line 3 executes. You see what happens. And so at every single line of execution, you could be looking to see if the variables are changing exactly as you had intended them to be changed. And so it's kind of like a more powerful version of the print, because at every single line, you're getting a printout of what is happening under the hood as Python's executing it. Okay? Now, as you get good at programming, you're going to be able to do it with your mind, where you're going to be able to just kind of look at the code and imagine, the variables changing as you execute the code. But that's a little more, that's harder to do, a little more mature, and we'll get to that. It's something we'll have to practice more. Okay? So that's this unit. Hope you have a good day. Bye, everybody.